In today's lecture, we're going to take a closer look at acid-base reactions. Most organic chemistry can be considered to be an acid and base reaction. There are two classes of acids and bases, and they are Bronsted and Lewis. So let's go into more detail when it comes to Bronsted acids and bases. Anything that has a proton on it is a Bronsted acid. Anything that can accept a proton is a Bronsted base. Of course, some acids are so weak that we don't think of those protons as being acidic. We think of the deprotonated form of that weak acid being a strong base. Here we see a strong acid donating a proton onto an amine. The products are a very weak base and a weak acid. This reaction has an equilibrium constant of about 10 to the power of 16. At equilibrium, it would be unlikely that you could detect any of the reactants. So this reaction is written with a one-way arrow as it goes to completion. In reaction 1, here we see a weak acid donating a proton to a weak base. The product is a strong acid and a weak base. Now the equilibrium constant for this reaction is about 10 to the power of minus 6. At equilibrium, there will be a small but detectable amount of product present. Since both reactants and products exist at detectable concentration after equilibrium is reached, we write this reaction with equilibrium arrows. All reactions can be written with equilibrium arrows. We use the one-way arrows when we know that the reaction goes almost entirely to completion, or when we are choosing to consider only the forward reaction at the time. And now we take a look at nucleophiles and electrophiles. Addition of an electrophile to an alkene. In this case, a double bond is a weak nucleophile and reacts with a strong electrophile, like the proton of a strong acid. We see in this example the electron pair of the pi system donates into the proton. Protons, hydrogen atoms, can only have one bond. So the electron pair of the H-Br bond moves to the bromine. In reaction 3, in this example, we see the electron pair of the pi system donates into the proton. Protons, hydrogen atoms, can only have one bond. So the electron pair of the hydrogen-bromine bond moves to the bromine. Bromine is fairly stable with a negative charge. It is, after all, an electronegative atom, and so it's an excellent leaving group. The above reaction could also be described as a Lewis or Bronsted acid-base reaction, and we'll take a closer look at that in our next lecture.